next thing we want to look at is the second thing that we need to do to increase the amount of stimulated emission so we can make our laser, and that is creating a resonant cavity. The reason why I want to create a resonant cavity is to build up the amount of photons that are going to be collected by this stimulated emission process. For example, if you just imagine you had this stimulated emission system with nothing enclosing the photons, right? You send the photon in, you get 2 photons out. You send the photon in, you get 2 photons out. But you never build up a significant number of photons because the photons you produce are just going out of the system. We want to build a cavity that is going to trap those photons in the system so that, if you send the photon in, you get 2 photons out. Those 2 photons then go back to the input. That creates 4 photons. Those 4 photons circle back, and you create more and more photons. So you get a buildup in these photons that are coherent, that they have the same frequency and the same phase. So for the purpose of this resonant cavity is really to amplify the number of photons that we have. So how do we make a resonant cavity? Well, let's start with that p-n junction. And this p-n junction needs some photons, needs a photon to go into there to trigger that stimulated emission, and we get photons out as a result of that stimulated emission, and we wanted to trap those photons in here. Okay, so let's put a mirror here. That will reflect any photons coming out of the p-n junction. And we'll put another mirror here. And that will redirect the photons back into the p-n junction. Okay, so this is our resonant cavity. Another thing that we have to make sure is that we choose the proper dimension for this resonant cavity. So we want that spacing between the mirrors to be some integer multiplier of the wavelength over 2. So we make sure that these photons are coherently multiplying or adding with each other. So n is an integer, 1, 2, 3, so forth. Now with this resonant cavity, I'm amplifying the number of photons a lot because they're all staying in the cavity, but it's not a laser because I don't get any photons out of here. I have my p-n junction in this cavity, but I never see any photons outside of the cavity. So you actually want to make one of these mirrors not a totally reflective mirror, but a partially reflective mirror. And this will allow for some of the photons to go outside of the cavity, and this is going to be the light that you see from the laser. And this is the basic structure of a semiconductor laser. This figure from your textbook shows a different way of making that resonant cavity. So you can see the p-n junction structure by cutting the crystal, the semiconductor crystal very precisely. These surfaces of the semiconductor crystal itself can act like the mirrors in that resonant cavity. So you have photons building up in this resonant cavity.